Okay, this is a video to go along with section 2.1 that has been partially covered in class. We've done a few examples of a few different types of equations. What this video is it's going to have the remainder of those problems worked out in detail so that you can watch them at your own pace and as many times as you want. So I'm going to go ahead and scroll down through all of the definitions because those were covered in class. And I'm going to start with example 1B because we did 1A in our coursework already. So what we're looking at here is a problem that has a decimal in it. Now, when I'm dealing with decimal problems, there's a couple different ways I can approach this. You could try multiplying by a power of 10 to get rid of the decimals. That's not always the best option because sometimes students will make mistakes, especially when there's something like a distributive property involved. So my actual recommendation is just to work with the decimals. It's not hard to do. You're allowed a calculator. So 0.3 times 3 would be 0.9. 0.3 times 2x would be 0.6x. We have our plus 1.2x equal to 3.2. We have like terms over here on the left side, so we're going to go ahead and add those together. So that would make 1.8x. Remember, when you add decimals, you line up the decimal and add column by column. This is still equal to 3.2. I would then want to subtract over the 0.9. So you can always use your calculator too. Remember, you don't have to do it in your head if you're not comfortable with that. So 3.2 minus 0.9 is 2.3. So right now I have 1.8x equals 2.3, and we would normally divide by 1.8. Now, I want to caution you, because this is in decimal format, a lot of people want to leave it in decimal format. In algebra, unless we're doing a word problem, we like to keep things in fraction or integer format. Let me show you a quick trick. If you have decimals that appear within a fraction, you can get rid of them by multiplying top and bottom by the same thing. Since there's only one decimal here, I'm going to multiply top and bottom both by 10. What that'll do is shift the decimal one place to the right. So this is just 23 over 18. And that would be our final answer because that does not reduce at all. Okay, so moving on to part C, this is a fraction equal to a fraction equal to a fraction. This is called a proportion. In like pre-algebra, that's usually where they first introduce this idea. When you have a proportion, it is a single fraction on each side. So one fraction equal to one fraction. You cannot have pluses or minuses. Okay? That's supposed to say fractions, not factions. Different thing. If you have that situation, you can do what's called cross multiply. Now, that has to have an equal sign in between them. If this was times, you can't cross multiply. It's only one fraction equal to one fraction when you can cross multiply. So we write this as 3 times 3x plus 1, because that's the first diagonal, equals 9 times 7x minus 2. We distribute that on each side, so that's 9x plus 3 on the left, and 63x minus 18 on the right. We need to get our x's on the same side, so I'm going to subtract over the 9x to be with the 63. And I also need to move the 18 over, so I'm going to add it to the other side. Notice I'm not doing it underneath, I'm just writing it as one step at a time, moving using the opposite signs. And then we combine our terms, so 63 minus 9 is 54. I could have done that in my head. And 3 plus 18 is 21. You need to divide by the one that is next to the x because that's what we're trying to isolate. And 21 over 54, I believe, will reduce. They're both definitely divisible by 3, I believe. Yes, so if we divide them both by 3, that would be 7 over 18. Now, I do want to mention one thing. I didn't talk about this at the beginning of the problem. Because this had a denominator that had a variable in it, So as I was saying, sorry, I had a student at the door. The denominators in this fraction have variables in them. Anytime that happens, you have to be very careful with what type of solutions that you say are correct. And what I mean by that is your denominators cannot equal 0. Those are restrictions. In Unit 2, we will formally define this as the domain and a domain restriction, but right now we're just trying to keep it very simple. So the denominators cannot equal 0. So I always double check by setting each one of them equal to 0. So this is just kind of a little piece I like to do to make sure my answer is okay. Let's add 2 over. So it looks like 2/7 is a bad value for this first fraction, and 3x plus 1 is the other denominator. We would subtract 1 and divide by 3. If you solve each of those denominators for 0, that will tell you what values on the number line are not acceptable for solutions. So this right here, 7 over 18, is fine because it's not 2/7 and it's not negative 1/3. Okay, that takes us to part D. This one's a little tricky because they try to throw you off by having all these fractions on the left, but they're all the same denominator. So essentially we can add these fractions together. So when you have the same denominator, you add them together and you keep the denominator. So 3 plus 6 is 9, minus 1 is 8. And I can write this as 11 over 1 if I want to. That way I can see that this is actually a proportion. By the way, before I go any further, y cannot equal 0 because you have a y in your denominator, and if it was 0, that would be undefined. So as long as our solution is not 0, we should be okay. So if we cross multiply, we get 8 times 1 equals 11 times y. That's 8 equals 11y, and we divide by the 11 since it's connected to the y. And that is not 0, so we are okay. That takes us to E. Oops, excuse me, went too far. E is not got any fractions, so we don't have to worry about domain restrictions for this one, but we have these things that are being squared. The reason this one is usually missed by students is because we try to just square things. We don't pay attention. You can't apply the square inside if there's either a plus or a minus. So what this means is you have to write it twice and then distribute it out. So I'm going to just rewrite this equation with these expanded to the same thing times itself. We then distribute, so this would be x squared plus 5x plus another 5x plus 25 plus the 3 that was already there. The other side would be x squared minus 2x plus 4 because it's negative times negative. Combine like terms on the left and like terms on the right. Notice that in this scenario, we're getting x squareds, and that's like, oh no, we have x squareds, because we haven't talked about how to solve any problems with x squared yet. That's kind of the next section. But what we have to realize is that when you try to move this x squared over, it's going to cancel out on both sides, because when you subtract it, it cancels both. So this actually really isn't a quadratic. It just looked like a quadratic at the moment. And that can happen. Sometimes something will look like a more complex equation, but as you start solving it, pieces cancel out. So I'm left with just the 10x plus the 28 and the negative 4x plus the 4. I need to add the 4x over to be with the 10 and subtract the 28 over to be with the 4. That would make this 14x equals negative 24. Divide by 14 since it's next to the x and reduce the fraction. So this one we can divide both by 2, so this would be negative 12 over 7. And notice I'm giving you lots of equations where fractions are the solutions. I want you to realize that not every equation comes out to a nice answer. Okay, the next one is another proportion. It has variables everywhere, but the only ones that matter for the restrictions, so this member is called domain restrictions or values that cannot be solutions since they would cause zeros. To figure those out before you start, you set each of the denominators equal to 0, solve for x, and then whatever you get is not supposed to be a solution. So 3/10 is one of our restricted values. we would subtract 3 over from the next one and divide by 2. So -3/2 is also bad. If either of these pop up as my final solution, I will have to throw them out. Now I do want to point out this one's a little bit more complex when you go to cross multiply because you have binomial times binomial. It's usually safer to write that out before trying to FOIL. So there's the first diagonal and then the second diagonal. Let's separate that. We're going to distribute. So 5x times 2x is 10x squared. 5x times 3 is 15x. 2 times 2x is 4x. 2 times 3 is 6. 10x times x is 10x squared. 10x times -8 is -80x. -3 times x is -3x. -3 times -8 is +24. Combine our like terms in the middle of each side, so that's 19x. This would be -83x. Notice again that when I go to move the 10x squareds over, so I'm just showing this really quickly, to be together, they are going to cancel on both sides. So I have 19x plus 6 equals -83x plus 24. I'm going to add the 83x over to the left and subtract the 6 over to the right. So this would be, let's see, that's going to be pretty large. 12, carry the 1, 90, no, 102x on the left, and 24 minus 6 is 18. So then when we divide by 102, since that's the one that is connected to x, always make sure you divide by the one that's connected to x. Let me double check my math on that because I'm doing that in my head. It was 19 plus 83. Yes. Okay, so we would divide these to see if we can reduce it down. It looks like it's divisible by 2, so that would make this 9 over 51. And notice neither one of these answers is 9 over 51, so our answer we got, neither one of the undefined values are our answer, so we can count our answer as correct. If you always want to be safe, you can plug your answer in. So we did G in class. I'm going to skip down to H. The first thing I would notice here is that you've got this constant term by itself over here connected to this fraction. If it was me, I would subtract that over first. But when you do, it gives you a 0 on the right side. That does not mean that we can't solve this. We can, we just have to do 0 over 1 so we can cross multiply. Now, sometimes when you get 0 on one side and there's not a 0 on the top, you should realize right away that it's going to be no solution, but you can still go through the solving process. Because what happens is that anything times 0 is 0 and 6 times 1 is 6. That does not make sense. So this means that since this doesn't make sense, there was no x left to solve for, this is no solution. So I wanted to make sure you saw a no solution case. And this one wasn't based off of the dividing by 0. In fact, the only thing that could have caused problems in the denominator would have been if the solution had popped up as -11/2. The reason this is no solution, this is our restriction. The reason this is no solution is because as you solved, all of your x's went away and the leftovers didn't make sense. Okay, I'm going to be doing I in class, so let's talk about J. For J, we have 2 fractions on the left and a number on the right. You cannot cross multiply unless you have a single fraction on each side. Now, one way to try to approach this would be to try to get common denominator and add the 2 fractions together and then cross multiply. That is an okay way to go, or you could just multiply everything by the LCD. So what I do is I usually factor all of my denominators. God, this is over 1. This is nothing I can pull out, but I can pull a 2 out of this pair. And when I do that, I notice a couple things. First of all, this is 2x plus 3, and so is this. My LCD now looks like I need a 2, but sometimes the part that's out front can reduce with what's on top, and in this case it can, because 2 goes into 6. That won't always happen. Sometimes you will have to use the 2 as part of your LCD, but I was lucky enough that 2 divided into 6. So I'm going to rewrite this, and notice I'm not canceling the 2x and the 2x here. This is different. This is a monomial. This is part of a binomial. When you pull a 2 out, it's now a monomial and a monomial. So that's why I was able to cancel there. So if I rewrite this, I now have this situation. And honestly, I don't think I'm going to multiply by an LCD unless I have to, but because I really could just add these two fractions together. But you know what? Let's just do the LCD method. Sorry, I'm very indecisive on this. When you do the LCD method, you multiply both sides by the denominator that they all have in common, and since this one is just 2x plus 3, that would be my LCD, because I've already reduced out that 2. And if we distribute that across this left side, that's going to cancel out both of those denominators. So I'm going to write it separately over here. 2x plus 3 times the first fraction plus 2x plus 3, so this is just me distributing, times the second fraction equals 2x plus 3 times the right stuff, which was 5. Okay, the 2x plus 3's are gone on both of these fractions right here, so that just leaves me with the numerators because this is all that's left. So it's a 2x for the first term and a positive 3. Over here we have to distribute the 5 to that, so that would be 10x plus 15. And then I would move my 2x over by subtracting it and my 15 over by subtracting. So notice I'm just moving these all at the same time. 2x subtracts over to go to the 10x, 15 subtracts over to go with 3. So this would be negative 12 equals 8x. So if I divide by the 8, since that's connected to here, notice I get negative 4, or no, sorry, they're both divisible by 4. I get negative 3/2. And I want to talk for a minute because did you notice that at the very beginning I did not talk about my domain restriction? This is why I wanted to point this out to you. If you do not take the time to look at your domains, you will miss certain problems. The domain is based off of what was in the original denominator. So this 2x plus 3 never needs to equal 0 or our answer doesn't work. So if I solve this over, notice that by the domain restriction, which I'm always doing in red, x is not supposed to equal negative 3/2. So this is part of my restriction, which means it's not a solution. So this actual problem is no solution, and it's because we can't plug something in that creates a 0 in a denominator. Okay, let's look at K. I would factor all my denominators first. We have a difference of 2 perfect squares down here on the last one. And notice that looks like that's going to be our LCD. So I need a 2x plus 3 and a 2x minus 3. You'll kind of get a feel for the pattern here. If I set this equal to 0, x cannot be, we would subtract 3 and then divide by 2. For the second one, I would add 3 and divide by 2. So neither one of these can end up being my final solution. All right, I'm going to use the LCD method again. So I'm going to write this out step by step. Take the LCD that you picked that represented all of your denominators, multiply it by each individual fraction in the problem on both sides. This is called clearing out the fraction with the LCD. It is only legal if you have an equation and if you do it to everything on both sides. 2x plus 3, 2x minus 3, running out of room, and my last fraction is 5x plus 6. Oh, that's really hard to see. And I'm going to just put LCD here because I don't have any more room. And this first one, the 2x plus 3's are canceling, and you're left with a 2 and a 2x minus 3. So you bring down both parts. I like to distribute afterwards because there's a lot going on up here. In the second group, the 2x minus 3's cancel, and you're left with a positive 4 and a 2x plus 3. In the last one, the LCD matches exactly, and we would just have the 5x plus 6 left on top. Okay, so at this point, notice that we don't have any more fractions, and we just need to solve this equation. So we would have 4x minus 6 for distributing the first part, plus 8x plus 12 equals 5x plus 6. Adding like terms on the left, that would be 12x plus 6, because 12 minus 6, equals 5x plus 6. Subtract over the 5x to the left, and subtract this 6 right here over to the right. That gives you 7x equals 0. That doesn't mean there's no solution. That means that if you divide by 7, 0 divided by 7 is 0. And since that's not one of those restricted values, this is the solution. Okay, I have one more of this type, and then we're going to talk about one more piece that belongs in this section. So this one also looks very similar. I can factor this into two perfect squares again. It won't always be the perfect square scenario. Sometimes this is a trinomial that you might have to factor. So then my LCD looks like it would be a 2x plus 5 and a 2x minus 5, which means my restricted values are, can't have, let's see, if you solve this, this would be subtract 5 and divide by 2. This would be add 5 and divide by 2. So we use our LCD to multiply with every part, and you kind of get to a point where you don't need to show as much work. So let me show you how I kind of walk myself through this when I don't want to show all of those steps. I just remember that these two things have to be distributed to every fraction here, and every term, essentially, even if it's not a fraction. So when you multiply this times the first one, your 2x plus 5 will cancel for that case. So that would leave you with the 2 on top and a 2x minus 5. So essentially, it leaves you with the numerator and the part that you didn't have in the bottom. Plus, on the second group, the 2x minus 5s will cancel, and you'll have a 3 and a 2x plus 5. On the other side, both parts will cancel that are part of the LCD, and you're just left with the numerator. We distribute. Combine like terms on the left, so that would be 10x plus 5 equals 10x plus 5. Notice when you go to try to move stuff around here, you'll subtract 10x over and you'll subtract 5 over. That gives you 0 equals 0. And you say, what? What does that mean? Well, anytime all of your variables cancel out, either the two numbers left behind will match, which they do here, or they won't match, like the other case we saw a minute ago when it was 6 equals 0, which did not make sense. When they don't match, it's no solution. When they do match, this is an identity. In an identity, it's all real numbers except any restrictions, because you still have to realize that this part right here is part of an original problem that had fractions with denominators with variables. So this would be all reals except negative 5/2 and 5/2. And all real numbers just means the entire number line, except anything that makes zeros in your denominator. So that's why those have to be written that way. If you write all real numbers, it is technically wrong because you would be including the two restricted values. Okay, the last piece of this section, and I'm going to do a couple of these in class as well, so I'm just going to hit the ones that I don't cover in class. This is called formulas or literal equations. A lot of times we will encounter a formula where you see a lot of variables are all being related to each other by addition, subtraction, multiplication, or division, even powers. So what we want to do is, can we solve these for a specific letter or variable, essentially? So for example, this first one says, take this equation that we give you, or formula, and solve it for C. What this means is get all C values on one side and isolate by opposite operations. Opposite, let me write that out. Sometimes it doesn't help to abbreviate too much. So opposite operations. For example, Notice that there's C's on both sides. There's two C's over here and there's a C here. I'm going to move the PC term over, and you do it the same way you solve anything. Because you're moving an entire term, you're either adding or subtracting. This is positive, so when it moves to the other side, it will be negative. Notice all three terms on this side have a C. If they all have the same thing, it can be pulled out as a GCF. And the reason you want to do that is you want a singular C to solve for. So if I pull the C out, this would be D. The middle term does still exist. It would be a 1 and minus P. Then notice this C is connected to all of this by times, so my final answer is to do the opposite of times. I would divide those three terms that were connected to C over to the other side. Notice this doesn't look any prettier than what you started with, but your goal was to get C by itself, and we did. I will be doing B in class, so we're going to skip that one for now. C says isolate I. Well, the problem is I is in a denominator. So if you think about this being over 1, and this is my I, I'm going to make that distinct. I would cross multiply here. So this would be R times I equals 1 times V, which is just V. I have a singular I on one side. I just need to get it by itself. So I'm going to divide by R. So I equals V over R. So that one was actually not too bad at all. For this next one, we need to get the R by itself. Okay, so notice the R is in this term. There's no other terms that have an R. So that means the first thing you should do is get any terms that don't have the R to go on the other side. So I'm going to subtract over that P that's by itself. Now this is all times, so that means to get rid of these, I can just divide. I would not suggest trying to do any kind of splitting and reducing of this fraction. I would just leave it as A minus P divided by P times T. The P's do not cancel out because this is a binomial and this is a monomial. There is no rule that allows you to partially cancel. Okay, for the next one, we're trying to solve for R, or excuse me, for H. Can't even read my own writing. So that means that you have to look at this a little bit differently. First of all, I see two things that have H's, and they're already on the same side together, so that's good. But there's also this distributive property and this other term that doesn't have H. Sometimes you have to clean up the processes before you can isolate it. So I'm going to distribute that 2 first. So 2LW plus 2HW plus 2HL. Anything that does not have an H should move to the other side. So I'm going to subtract the 2LW. These terms on the right both have H, so I'm going to pull the H out. Once you have everything on that side that has the same variable that you're looking for, you pull it out. That leaves me with 2W plus 2L. Now that this is multiplication, you can divide that whole parentheses to the other side. So S minus 2LW over 2W plus 2L equals H. And again, doesn't look any prettier. I'm sorry, that kind of looks like a 5. That is an S. This doesn't look any prettier than what we had, but it is solved for H. Okay, I'm going to do F with you guys because the G one is the last one that I'm going to cover in class. This one's a little tricky because you're trying to solve for Q and it's in the denominator. Anytime it's in the denominator, we're going to have to get it out by either doing cross multiplication or clearing by an LCD. But there's also this distributive property that's kind of making things difficult as well. So the first thing I'm going to do is distribute that P to make it a little bit more simplified. And that would be minus PQ at the end. I'm going to think of this S being over 1, and then I'm going to cross multiply. The S is going to have to multiply times all three parts that are on the denominator, and P times 1 is just P. So now the Q's are now on the same side, and they're no longer in a denominator, but they've got this S out front. So we need to distribute the S, and then anything that does not have my Q needs to move to the other side. So this SP needs to be moved over by subtracting. So now all I have is the SQ and the SPQ on the left side, and on the right side I'll have P minus SP. Notice this one is the one I subtracted over to this side over here. And then I can pull a Q out of that pair that's on the left. So that would be S minus SP. And by the way, I made a little uppercase P here. You should keep all of your letters in the same case that they're supposed to be in, like if they're uppercase or lowercase, because WebAssign does not like that if you change that, so be aware of that. And notice these do not add together. I know they both have S's, but because there's also a P on this case, you cannot subtract or do anything with that. If you wanted to, you could pull out an S, but it doesn't make it look better because we're going to try to move this over to the other side to get the Q by itself. So then I would divide by that piece. Now finally, when I get to this point, I do look and see if there's anything I could cancel out. On the top, we could pull out a P. That would leave me with 1 minus S. On the bottom, you could pull out an S, and that would leave you with 1 minus P. So since it didn't help us cancel anything, this is okay or this is okay. I'm really not picky about which format you use. But this was better to at least know that for sure nothing is going to cancel out. And you cannot cancel out the SPs. Remember, the rule is when you're trying to cancel something, monomials can cancel with monomials. If it's a binomial, it has to be identical, or you have to be able to pull something out that matches. So we cannot do anything with either part of this. And that is the end of this video. So hopefully that will be something you can watch over and over again and help with reviewing solving equations.